Alright, in this video we're going to talk about section 1.3 day 1, right triangle trig. So recall from geometry that these 6 trig functions can be related to a right triangle in the following ways. So sine of theta, and theta is going to be one of our acute angles. Sine of theta is opposite side over the hypotenuse. Cosine is going to be the adjacent side over the hypotenuse. And then tangent is going to be the opposite over the adjacent. So that's your SOHCAHTOA stuff. Cosecant is going to be the reciprocal of your sine. So instead of opposite over hypotenuse, it's going to be hypotenuse over the opposite. Secant is the reciprocal of cosine, so we can think of this as the hypotenuse over the adjacent. And we can think of cotangent as the adjacent over the opposite sides. So if you know your sine, cosine, tangent, if you remember those from last year in geometry, then you know the other ones, cosecant, secant, cotangent, because they're just reciprocals of the first three. So we can use those to solve a triangle. So in this case we can use the given triangle to find these 6 trig functions for the angle theta. So theta is here, 3, 4, and then they don't tell us the hypotenuse, so you either know that this is a 3, 4, 5 right triangle, or if you don't, you can use the Pythagorean theorem. 3 squared plus 4 squared, so that's 9 plus 16 is 25. Square root of 25 is going to give us 5. So, using what we just saw a second ago, sine of theta is going to be the opposite 4 over the hypotenuse 5. Cosine of theta is going to be the adjacent 3 over the hypotenuse 5. Tangent of theta is going to be equal to the opposite 4 over the adjacent 3. Now we get to our cofunctions. So sine is paired with cosecant. So cosecant is going to be 4/5. It's just the reciprocal of sine. Secant is just the reciprocal of cosine, so that's 5/3. And cotangent is the reciprocal of tangent, so that's going to be 3/4. So just a little bit of a review from geometry, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then cosecant, secant, cotangent are just the reciprocals of sine, cosine, and tangent respectively. So a little bit more review from geometry. Find the values for sine of 45 degrees, cosine 45 degrees, and tangent 45 degrees. So what we should probably deal with, just to help ourselves a little bit, is draw ourselves a triangle. So let's go ahead and label this as 45 degrees right here. Now, if you think about this, there's 180 degrees in the triangle. We have a 90 degree here, so there's 90 left. We've used 45. So we know that's going to be 45 also. So we know that it's an isosceles right triangle. So we know that this side here and this side here are going to be the same. We can really pick anything we want because these are just ratios and everything will divide out evenly. So let's just pick a nice easy number and say that has a side length of 1. That has a side length of 1. So to figure out the hypotenuse, we can do 1 squared plus 1 squared is going to be 2. Take the square root, and we get radical 2. So we can think about sine of 45 degrees as the opposite 1 over the hypotenuse radical 2. Rationalize, so we're going to get radical 2 over 2. Cosine of 45 degrees is going to be the adjacent 1 over radical 2. Again, let's rationalize. We're going to get radical 2 over 2. And tangent of 45 degrees is going to be the opposite 1 over the adjacent 1, which is just going to be 1. Now this shouldn't be a surprise because we know from our unit circle that 45 degrees is the same thing as pi over 4 radians. And you should know that sine of pi over 4 is radical 2 over 2, cosine of pi over 4 is radical 2 over 2. So these answers really shouldn't have been all that crazy. Let's look at a 30, 60, 90 though. So values of sine, cosine for 30 and 60. So again, let's draw ourselves a picture. If we call this 30 degrees up here, so it's got to be across from the shorter side, we'll call this 60 degrees here. Again, we can kind of pick whatever we want, but if you remember your special right triangle relationship, this is going to be 1, 2, and radical 3. Oh, nope, I'm sorry, I have these two switched. 2 is our hypotenuse, that's bigger than radical 3. 1, 2, and radical 3 as far as our short side, hypotenuse, and long side of our triangle. So if we're going to try to find sine of 30, well, we want the opposite, 1, adjacent, or I'm sorry, hypotenuse, 2, so that's going to be 1/2. Cosine of 30 degrees is going to be the adjacent, radical 3, over hypotenuse, 2. Then we can look at the sine of 60 degrees. So across from our 60 degree, we have radical 3, hypotenuse of 2. If we're looking at our cosine of 60 degrees, we take the adjacent, which is 1, hypotenuse, which is 2, we get 1/2. And just like the last one, this shouldn't be a surprise because 30 degrees is the same thing as pi over 6, and 60 degrees is the same thing as pi over 3, and we should know sine and cosine of pi over 6 and pi over 3 radians, and spoiler, they're right here. Alright, so the last thing that we're going to talk about in this video are some fundamental trig identities. So these are things that are true no matter what the angle is, and they might help us solve some problems here and there. They're not absolutely necessary, but they might make our lives a little bit easier. So the first ones are ones that we've actually already talked about earlier, and it's the fact that some of these things, some of our trig functions are reciprocals of each other. So we mentioned before that sine and cosecant are reciprocals, so we can think of sine of theta as 1 over cosecant of theta. Likewise, cosine could be 1 over secant of theta, and tangent can be 1 over cotangent of theta. And then cosine, these ones up here we're probably not going to use very much, but these ones here we will. 1 over sine of theta, 1 over cosine of theta, and 1 over tangent of theta are going to be cosecant, secant, and cotangent respectively. Those ones are going to be pretty useful. Tangent, we're going to use these two all the time. Tangent is going to be the same thing as sine of theta over cosine of theta. And then likewise, cotangent is going to be cosine of theta over sine of theta. And we've already kind of talked about that in a previous lesson when we were talking about x's and y's. We said cosine is x, sine is y, and tangent was x over y. So if you do a little bit of substitution, you can end up at this quotient identity. And lastly, we can have some Pythagorean identities. So instead of a squared plus b squared equals c squared, we can think of this as sine squared plus cosine squared equals 1. If we divide everything here by a cosine squared, so sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is going to be secant squared. And we can also think about this last one, 1 plus cotangent squared is going to be cosecant squared of theta. Same idea, except this time we're going to be dividing by sine. Now your Pythagorean identity here is going to come from just any point on your unit circle. So we'll just pick a random one here. If we were to connect that, we know this point lies on the unit circle. So its hypotenuse, if we make this a right triangle, is going to be 1. From here to here is going to be your cosine value. And from here to here is going to be your sine value. So cosine squared plus sine squared equals 1 is the same thing as a squared plus b squared equals c squared. Alright, so let's use those in an example, and then we'll call it quits on this video. So let theta be an angle such that tangent of theta equals 3. Find the values of cotangent and secant. That's actually a typo. I apologize. That should say secant squared of theta. So the first thing we want to think about we know that tangent of theta equals 3, and we want to know cotangent. So we know cotangent is really just 1 over tangent. So cotangent is going to be 1/3. And since we changed this to secant squared, we know something about tangent. So we can look at the Pythagorean identity that says secant squared of theta is going to be equal to 1 plus tangent squared of theta. Well, we know tangent is 3. So we know that secant squared is going to be equal to 10. So to figure out what just secant is, we're going to get square root of 10. And actually that's why that was just plain secant. But we're going to use the secant squared because that relates secant to tangent. So that's going to do it in this video. We will see you in the next one.